Hello friends, good morning all of you. Welcome back to the class. I hope you all are safe at home and healthy too. Now, in this session 4, in sets topic, we are going to understand the Venn diagram concept today. So, it's very interesting concept in set theory which is being developed by John Venn to understand the operations less like addition, subtraction, multiplication of numbers. In a similar way, we are having addition, subtraction, and difference. That is what plus, minus, and whatever the complement operations based on sets is being simply be understood by this diagrams which is developed by John Venn. That's why this diagrams named after his name like Venn diagrams. So what are these Venn diagrams and what is the use of this Venn diagrams in our daily life and how they are related to set theory concept we'll try to understand in this session. Now see, so here John Venn is introducing this diagram by specifying two things about the universal set and its subset. So first you need to understand the term the universal set. What is meant by the universal set here? First, what is universal set? Try to understand the meaning of universal set. What is universal? It's simply a set which contain all the given sets as a subsets. Let us say, to understand the definition of universal set, I am taking few examples. Set A representing the set of, let us say, positive even numbers, dot dot dot. Set B representing the odd numbers, 1, 3, 5, 7, dot dot dot. Similarly, set C representing the prime numbers 2, 3, 5, 7, 11, dot, dot, dot. Now I am taking one set, I am introducing the set which will be the universal set for all these three set of whole numbers. Our set of natural numbers can also be, right? 1, 2, 3, 4, 5. Now you can simply say the set of whole numbers, right, is containing set A, set B, set C. All these sets are the part of whole numbers, are part of this natural number. Hence, the whole number set can be considered as the universal set for all these three sets. Hence, universal set is a set which contains all the given sets. Hence, all the given sets are the part of universal set. Hence, we can say every given set is a subset of universal set and universal set is said to be superset of given sets. I repeat, every given set is a subset of universal set and universal set is said to be superset of all given sets. So this is the definition of a universal set. Universal set is basically denoted by capital U. And there is another symbol to represent the universal set, that is epsilon. See, epsilon, right? Again, it's a Greek symbol which is used to represent the universal set. Now, with the help of this definition, we are going to describe the Venn diagrams in detail. What is Venn diagrams? And before start the Venn diagram, there are two rules to be followed. One is here he just preferred, John Venn preferred only two types of polygons. One is the rectangle and second is a closed curve. Basically he was using circles. You may also use ellipse, that is what orbital shapes, and any other closed figure like triangle, square, parallelogram, many more. But in set theory language we are taking only two closed figures. One is rectangle, second is a circle. Rectangle is used to denote the universal set and the subsets of universal sets are represented by A. means the set A is represented by a circle. Set B also represented by a circle. Set C also represented by a circle. And universal set is represented by rectangle. So every set is a subset of its universal set, hence these circles are always drawn inside the rectangle because they are the part of rectangle, and the elements which the set is containing is simply written in this circle. Getting? So now with the help of rectangle and these circle symbols, right, we are going to understand few fundamental operations which are listed over here: union, intersection, difference and symmetric difference. One by one we'll try to understand what is meant by union and how it can be represented with the help of Venn diagrams and all. Fine. So let's try. Now first we are going to understand the operation union. What is meant by union? Union means, let us say, if there are two sets having the elements, let us say I am taking the finite sets here, 1, 2, 3, 4, and the set B having the elements E, 3, 4, 5. Now I wanted to combine these two sets to generate a new set. Just like in a numbers, 2 rupees and 3 rupees, what is the total number of rupees will be 5. In that sense, if set A has this element, set B has this element, if I combine both the sets, what is the total number of elements left? And that is represented by the symbol union, that is A is combined with B, that is total number of element present in A और B और both. हमें A और B के सारे elements count करनी है. While counting, repetition is not allowed. You know that it makes no sense. Hence, A union B is written as 1, 2, 3, 4, 5. Now I have eliminated the repetition of elements while counting the elements. So this is called A union B. It's so simple to understand. Nothing, we need to combine all the elements which are present in A and B. Both. दोनों में जो elements है combine कर दीजिए, that is called as A union B. Now how this could be represented through Venn diagram? See. Let us say here the universal set representing the natural numbers till 10. Okay. Now how can I represent the A union B, right, through a Venn diagram? So I will definitely draw first one rectangle which is always showing a universal set, and then we are drawing two sets with the help of circles, right, A and named it as B, and we know that there are some elements common, that is why I have drawn the overlapped circles. Overlapped means some elements are common, that's why I am showing through a diagram that these two circles have some common elements by just simply drawing the overlapping circles. Now what we have, 1, 2, 3, 4, 3, 4, 5, but 3 and 4 are the elements which are in a common area, that's why 3 and 4 the elements are written in a common portion, right, and the rest here 1 and 2 and here 5. Now you can see set A elements are 1, 2, 3, 4, set B elements are 3, 4, 5. 3 and 4 are the elements which are common in both the sets, and these are the parts of universal set, hence this is represented through the Venn diagram. Now it is what the example, but if I want to show simply A union B, so what I can draw here, universal set A and set B. So if I want to show A union B, how A union B can be defined, see, that can be simply by shading the entire A and B. See, so this shaded portion representing A union B. So I can say this red shaded portion representing A union B. So this is the general way of representing the union of two sets. So this is an example where you can understand what is the meaning of A union B, how it can be represented through Venn diagram wherever it is required, and what is the general representation of A union B? It's simply by drawing a rectangle and then two overlapping sets, we considering that there are some elements common in both the set. That's why we are drawing like this. And the shade the entire portion of A and B, because in A union B we are taking the elements of A as well as on B. And finally the set union of this set is representing through set builder form, like A union B is representing in set builder form that X such that X belongs to A or X belongs to B. So whatever the elements we are taking, either they are in A or in B or in both. Hence this union of the sets representing through set builder form, like X says that X belongs to A or X belongs to B. So we are representing the A union B in roster form, set builder form, as well as through Venn diagram. So to represent the operation union of the sets, we are having three different types of representations. One is the roster form, which we called also listed form, set builder form, also known as property form, which we have studied these two forms in the previous sessions. Apart from that, in this session, we are representing this operation through Venn diagram. That's why it's also called what? Pictorial representation of the operation union. So here the definition of union is over. Now we'll try to understand few important properties related to union and what are they. See. I'm just listing the properties of union in short manner. You may also verify these properties by taking the help of examples. Okay. So now I'm simply writing A union B is simply equal to B union A. Just like in addition, 2 plus 3 is always equal to 3 plus 2. So while adding the numbers, order is immaterial, order is not important. Similarly, while doing the union operation, order is not important. While whether you are doing A union B or you are doing B union A, both are giving the same number of elements. They are the equal sets. Therefore, this union is called commute. What do they commute? They are following commutative property. This is called union is commute. Similarly, A union of B union C, union of three sets, is also be done in any order. किसी भी order में आप union find कर सकते हो. B union C का पहला find करें, उसके बाद आप A union के साथ करें, या A union B first find करें, बाद में S union C करें. These are always same, giving the same equal elements. Hence, union of the sets is called associative. So union of set is commutative also and associative also. Now the third, A union A will give A only. एक सेट को उसी सेट के साथ यूनियन फाइंड आउट करेंगे तो अल्टीमेटली वही सेट रिपीट होगा. So what we called as union of a set with the same set gives the set itself, which we called as idempotent law. Idempotent law. Idempotent law means it simply says union of the set itself is give the set the same. So A union A is always gives A. Then The fourth one, law of pi. Law of pi means if a set is a non-empty set, set A is a non-empty set, pi is a null set, then A union pi, by combining these two sets, you always get set A only. Hence, this is called what? Law of pi. Similarly, the last one is A union universal set. It will always give the universal set. Means while doing the universal union operation, you always get the result which is equal to the biggest set और among these two sets जो भी होगा जो बड़ा होगा वही set उसका result बन के आएगा, right? So definitely universal set is always the bigger set than A. Hence the A union universal set will always give universal set only, and this is called what? Law of universal set, law of U. So there are five important properties you need to remember, you need to understand. One is the union of the set is commutative, union of the set is associative, law of idempotent, law of U, law of pi, nothing else. It's so simple to understand as well as to remember. Now coming to the next portion, that is next operation, that is intersection. Now what is meant by intersection of the two sets or more than two sets? Try to understand. Right. So I am taking here intersection concept. What is meant by intersection? Intersection of two sets is denoted by inverted U. Inverted U. This is a symbol used to represent the intersection. Intersection means in general language I can say common elements. What are the common elements between the two sets? That is we called as intersection. Let us say, again I am taking the regular example 1, 2, 3, 4 and set B as an element 4, 5. Now, what is the intersection of these two sets? A intersection B means what are the common elements we are having in both the sets. That is the only element 4 is common in both the set. Hence, 4 is a common element in the A and B. So we are only focusing on the common elements in given two sets. So that is termed as intersection of these two sets denoted by inverted union. Simple. Okay. So now with the help of this example, now I can show the same set through a Venn diagram by drawing U as a universal set and two sets A and B, right? So hence what I am speaking here, universal set के अंदर मैंने दो set लिया which are overlapping and 4 is the only element which is common. That's why first I will write the common element in both the sets, then I will fill the remaining elements of set A 1 2 3 and here 5. So I simply represented that intersection of the given two sets with the help of Venn diagram. Now, what is the general representation of intersection of two sets that we'll try to draw here? It is a general representation of union of, intersection of two sets. It's A, it's B. Now, what is the intersection of the two sets? See, I'm just shading the common area of the two sets. So this is called what? Intersection of two sets. This portion represented by A intersection B. So this representation is called a general representation of intersection of two sets. Now with the help of this, now we are going to write these intersection of the two sets in a set builder form. What is a set builder form speaks? A intersection B is a set of the elements X such that X belongs to A and X also belongs to B. Now you can see the language I am using. I am using the AND word because whatever the elements we are taking in A, that also in B, that is why it's called A intersection B, which is a symbol used which is exactly vertically inverted of union symbol. Fine. So now in a similar way, we'll try to understand some important properties of intersection. So intersection property. Again the same way, just like we have discussed in the union concept. First is A intersection B is equal to B intersection A, which is called commutative property. Means while doing the intersection, also order is not important. Anyway you can do the operation. Similarly, A intersection of B intersection C is always equal to A intersection B intersection C, which we called as what? Associativity or associative property. The intersection is associative. Then the third one, A intersection A is always give A. किसी भी सेट का इंटरसेक्शन अगर उसी सेट के साथ आप फाइंड आउट करोगे, then their intersection common element means all the elements of that say will counted. Hence, intersection is following the idempotent law. Idempotent law means identical, एक जैसा. Then A intersection null set will always give null set, which will all called law of pi. Law of pi means there is no common element is possible with the null set. Null set has no element at all, hence there is no common element, hence the result will be a null set only. And the fifth one, A intersection universal set is always give A only because A is a subset of U, hence A intersection U will always give A, which we called as law of U, law of universal set. So simply five set of rules you need to understand, which is called intersection properties. Now I'm just adding the one important property which combines the union and intersection both, which we called as like A union B intersection C will simply distribute this union over the intersection, which can be written as A union B intersection A union C. So this we called as distributive law. Distributive law means you can distribute union over intersection, intersection over union. That we called as distributive law, which will combine the both the symbols union and intersection. This is the only law which we call as distributive law, right? Just you need to remember, nothing else. We have studied distributive law in our elementary classes like A into B plus C is equal to A into B plus A into C. So multiplication, distribution over addition. In that way, union is distributing over intersection. Intersection can also be distributed over union, vice versa. So now, by keeping these points in our mind, we'll try to understand the small topic that is difference of sets. Achha. First, before understanding the concept of difference of two sets, I would like to introduce the disjoint sets with the help of intersection concept. Now, what is the disjoint sets? Is a type of sets you can also say with the help of this intersection only you can understand disjoint sets. There is no joint, there is no common. What are the disjoint sets? Means here. if set A has the element set of, let us say, even numbers 2, 4, 6, set B has the element set of odd numbers. Now, if I want to find the common elements in both the set, you will say, sir, there is no common element in a given two sets, hence it would be a null set. Hence, in this case, this A and B are called disjoint sets. There is no joint, there is no common in both the sets. So, how I can define the disjoint set with the help of intersection symbol? If any two sets gives, like A intersection B gives null set R pi, then given two sets are called disjoint sets. What I am saying? If intersection of any two sets is gives pi, then A and B are called what? Disjoint sets. Disjoint sets. Now, how we can represent this disjoint sets diagrammatically? That is what? Through a Venn diagrams. Now see, this is always universal set. Now I am just drawing the two circles representing set A and set B, set A and set B, but there is no overlapping. See, there is no common portion. Hence, I am drawing these two sets as separate circles and I am simply writing the elements which they are having. 1, 3 and 5. Now you can see there is no common element, there is no common portion, hence they are not overlapping circles. So to represent the disjoint sets, what we are using the Venn diagrams. In that Venn diagrams, we are drawing the circles separately, not overlapping circles. So this is a general representation of disjoint sets. So I hope you have understood the definition of disjoint sets. Now let's try to understand the third concept of today's session, that is difference of two sets. Now, what is the third concept? We have difference. Just like in a numbers, we have that 1 minus 2 is not always equal to 2 minus 1. We know that 1 minus 2 is not equal to 2 minus 1, means 1 minus 2 gives minus 1, 2 minus 1 gives 1, so minus 1 cannot be equal to 1. So the way we are doing in numbers, the same concept we can also understand here in the difference case. And now for that I am taking two sets. First, difference of two sets, A minus B. What does mean by A minus B? Elements which are in A but not in B. Simply we are removing the elements of B from A. Simply try to understand through an example. Set A has the elements 1, 2, 3, 4 and set B has the elements 3, 5, 7. Now what is A minus B says? A minus B ये बोल रहा है from set A take out the elements of B. A का हिस्सा में से एक set A में से B का element को remove कर दो. Right. Now what are the elements of set which are also in B? We can identify here 3 is an element which is in A as well as in B. That's it. Hence we need to remove that common elements. So hence what are the elements is left with us? 1, 2 and 4. 1, 2 and 4. A में से B का element को हटा के लिखना है in simple language. And whatever the elements in B, that doesn't matter. A minus B represent elements which are in A, not in B. Only A. What we called as only A. Other way to speak the difference of two sets is what here? Only A. Now, if I want to find B minus A means what? From set B, eliminate the set of A elements. B में से A का element को हटा के लिखिए. So B का element में से A का element कौन सा है? 3 हटा लेना है. So B minus A is what? 5, 7. Hence, From these two results, what we concluded, A minus B is generally not equal to B minus A. Are you getting my point? So difference of sets, two sets means set A minus B, it means the element which are in A not in B. Which element which are in A but not in B. So this can be written through a set builder form like X as that X is belongs to A but X is not belongs to B. Set A minus B representing what? Set of the elements which are in A but not in B. A में से B का एलिमेंट हटा के लिखना A में होगा but B में नहीं होगा. Similarly, B minus A is written as what? X belongs to B but X is not belongs to A. So this is a roster form we have understood, and the same can be represented in set builder form. Now we try to understand the same concept with the help of Venn diagram. What is meant by Venn diagram? How we can be representing this? See, I am just simply drawing A minus B here. So this is universal set, A set and B set. Now set A, set B. From set A, I am removing the B portion. So what is the B portion we have? This is a B portion where B is involved. So सर्कल A में से B का हिस्सा कट कर दीजिए. So ultimately what are the left portion? So this portion is called what? A minus B. Are you getting my point? A minus B मतलब सर्कल A में से B का हिस्सा हटा देना, right? Similarly, B minus A means सर्कल B में से A का हिस्सा हटाना है, यानी कि only B. So this portion, blue shaded portion is called B में से मैंने A का हटा दिया, B minus A. Are you getting my point? This portion, red portion is called A minus B, the blue portion is called B minus A. So in simple language, when I speak difference of two sets, I am always eliminating the common elements of both the sets. Are you getting? So hence what we called it as if A minus B means set element which are in A not in B. B minus A means set element which are in B but not in A. That can also be represented in various forms. Roster form, set builder form and through Venn diagrams. So this is a general representation of what we called as difference of two sets A minus B and B minus A. Now we are going to understand the last concept of today's session, that is symmetric difference. I am keeping the diagram same because I need it. Fine. So what we called as here symmetric difference. Represented by delta. The symbol which we called as what? Delta. This symbol is called delta. So delta representing the symmetric difference. What is symmetric difference speaks? Symmetric difference, it's simply the union of the two sets, that is A minus B union B minus A. So A minus B ka hissa, that is what? The set union B minus A. So it's a union of A minus B and B minus A, simply the red portion and the blue portion combinedly known as symmetric difference. So if I'm just doing the union of these two sets A minus B and B minus A, this red and blue portion combinedly known as what? Symmetric difference. So pictorial representation is also done, definition is also done. Getting? Now the symmetric difference can also be termed as, see, because I am just looking for this portion, this shaded portion can also be interpreted as सर A यूनियन B माइनस A इंटरसेक्शन B। आप जस्ट चेक करिए, क्या मैं ये कह रहा हूं कि टोटल A यूनियन B मतलब कंप्लीट एरिया होता है, उसमें से मैं सिर्फ कॉमन एरिया को सब्ट्रैक्ट कर रहा हूं। यू कैन सी A intersection B portion, this is what the middle portion, so hence from the entire region that is A union B में से हम कौन सा पोर्शन रिमूव कर रहे हैं, इंटरसेक्शन पोर्शन को रिमूव। Hence, this shaded portion can also be written as A union B minus A intersection B. So, delta can also be defined as just its a difference of union and intersection. Union and intersection. So, union operation में से intersection operation को minus कर रहे, so we are getting the delta that we called as symmetric difference. This can also be written as the several ways, only A and that is what only A and only B. अब check करिए, this red portion representing only A means there is no portion of B is involved. Similarly, the B, what we call as blue portion is representing only B. So, in general language, people also termed it as only A union only B will give the symmetric difference of two sets. So, there are various ways to represent, various ways to say the symmetric difference denoted by delta. The fundamental definition is A minus B union B minus A, also be termed as A union B minus A intersection B. ये कैसे पॉसिबल हुआ, इस तरीके से डेफिनेशंस कि जब हमने वेन डायग्राम को देखा था तो ये जो शेडेड पोर्शन है लोग अलग अलग तरीके से इसको इंटरप्रेट करेंगे विदाउट चेंजिंग द मीनिंग ऑफ डेफिनेशन. So you may speak the several ways to represent the symmetric difference further also. So this is all about the Venn diagrams. With the Venn diagrams, we have understood the four fundamental operations of sets thoroughly and very clearly, I hope. So here I'm just winding this session, and I'll definitely say with the help of this video lecture, you will be able to solve the fourth exercise, that is 1.4 exercise from NCERT textbook. You will be able to finish it. So I request all the students to please finish this exercise today itself after watching this video. And thank you for watching this, and thank you for your patience to watch me and to hear me. And keep watching, keep learning, and keep growing. Thank you, all of you, once again.